In this module, we're going to take a look at Combine basics. Now, Combine has some fundamentals that we need to understand before we can start to be really productive in it. Now, before I get into those, let's quickly discuss the requirements you'll need for running Combine. First, you'll need to be building in Xcode 11 or later. Now, this course is going to use Xcode 12. And for deploying, your iOS targets are going to need to be at least iOS 13, and your macOS targets are going to need to be at least 10.15 Catalina. Now let's talk about the first two fundamental building blocks of Combine, and that is publishers and subscribers. They are defined inside the framework like this. A publisher is a protocol that has two associated types, one for output and one for failure. I like to visualize it like this. Subscriber is very similar, except instead of an output, it has an input type. Now, when you subscribe a subscriber to a publisher, it's going to create a subscription. And in order for you to do that, the input type of the subscriber needs to match the output type of the publisher, and the failure types of both need to match up as well. I like to think of this as kind of like a US-style plug. It has a specific format, and you can only plug it into the specific type of socket, and it won't plug into the other one because it doesn't fit. And also kind of similar to Combine, you can buy adapters and transformers and things to adapt one style to the other, and we can do that in Combine as well. It's also worth noting that you can have one publisher and have many subscribers. Each of them will create its own subscription, and publishers are going to do work on demand. When you create a subscription, the publisher will start delivering its values, and eventually, if it completes, it will send a completion event, or if it fails, it'll send an error event. And it's worth reiterating that as soon as a publisher emits a completion or a failure, it's never going to emit another value on that same subscription. Now let's talk a little bit about code. So the easiest publisher we could think of is, say we have an array of ints here, 1, 5, and 8, and we just call publisher on that. This is a method defined by Combine that extends sequence. The output type of this publisher is int, and the failure type is never. Now, it's really important when you're working with Combine is to always be aware of the output type that you're working with in your publishers and the failure type you're working with. When things don't quite line up or you're getting compile errors, this is usually what you need to look at. Now, the failure type of never is a special case. This thing can never fail, and we're indicating that with a special error type of never, and Combine can leverage that knowledge in order to avoid us from providing necessary catch blocks or other kind of handling of failures, because we're indicating that this can't fail. And there's plenty of publishers that don't fail, and so you'll use never a lot. If you subscribe to this publisher, the subscriber would receive this: each element in the array, one by one until the array is done, and then a completion event. This works with other arrays as well. So here I have an array of strings. I call publisher on it. Now I've got a publisher of output type string and failure type never. And again, it's similar. It emits the elements from the string and then completes. But this works for any sequence, and string itself is a sequence as well. So if I call publisher on that, I'm going to get an array, or rather a publisher of characters with a failure type of never. And the output, if you subscribe to it, would look like this: each character delivered one at a time until the string is exhausted. Combine ships with a lot of very simple and useful utility publishers, and the first of those is Just. And the reason why you might use these will become more apparent later, but just know that sometimes Combine will expect you to return a publisher, or if you already have a value, you just want to use it, you can wrap it in Just and provide the value here. And this is going to give you a publisher of that value's type. So here I have a publisher of bools and a failure type of never. Now, to the outside world, I don't need to know that this is going to emit just this one static value. I just know that I have a publisher of bools. And if I subscribe to that, I get a true and I get a completion event. So whatever value you pass into Just, it's going to deliver that value and then complete. And that behavior of being a combined publisher allows you to take values that you already have and hook them into the Combine world. So for instance, if we had an endpoint that was supposed to deliver a Combine publisher for some remote network data, but we already had some cached and in memory, we could use Just and return the data that way. And this way, we are still returning a Combine publisher. Everything else about our code works exactly the same way, but we just had the value already. This can also be really helpful in exploration and testing, and so we'll use this a lot in our playgrounds. Now, similar along this vein is empty. And empty requires us to specify two generic arguments, first being the output type and the second being the failure type. Because combine can't infer this, we have to specify it. And empty's job is to A, be a publisher, but B, just complete. It will never emit any events. And this is why we need to specify the output type and the failure type, because the types have to line up for you to subscribe to it with a specific type of subscriber. But this is just saying, I don't have any values, I just want to complete. And so we can return empty. Again, just knowing that these are built-in publishers is enough for now. And then lastly in this vein is a fail publisher, which will take an error right now. And again, we have to specify the output type so the combine can know what type of publisher this is. And its job is just to fail with that error. So again, this is really useful during testing, or if you want to hook into the combine world and you already have an error. Okay, so now on to some more useful things. Combine ships with some publishers to extend foundation. So in this case, we have a notification center publisher, and all we need to do is say publisher for a specific notification. And now we have a publisher whose output type is notification and a failure type of never. So this is really, really handy. And this is basically how I deal with notifications these days. We also have notifications for timers. So if you call timer.publishEvery, and we can pass in a few arguments, one of which is the interval to fire this timer on. Now we have a publisher, and the value that we get for each of those events is a date and a failure type of never. So here's an example where we have a shopping cart that inherits from NSObject. It's got a total property, and we create an instance of this shopping cart. Now we want to observe the total property. One way we can do that is with key value observing, and combine ships with an extension on NSObject, which allows us to get a publisher for any key path, and that's going to hook in using key value observing. And now we have a publisher that will produce values of whatever that key path type is. So in this case, our property is of type double, and so this is going to give us a publisher whose output type is double and the failure type is never. Okay, let's take a look at some subscribers. So there are two built-in subscribers that you'll use for basically everything in Combine. There are sync subscribers and there are assign subscribers. Let's talk about sync first. I'm going to create a function called sync example manual, and then I'm going to call it here. I just want to do this so we can isolate one example at a time. And here, what we're going to do is we're going to create a publisher, and this is going to be a publisher similar to what we've seen before. We're going to do a publisher of ints. So now I have a publisher of ints, and I can now create my subscriber, and this is going to be something that comes from the subscribers namespace. And so this is going to be subscribers.sync, and you can also see subscribers.assign there at the top. So subscribers.sync takes two generic arguments. The first is the values that this is going to receive, so int in this case, and the second is the failure type, and never is our failure type that we're producing from this publisher. Now, if I don't have these things matching up with the publisher, then I can't connect them together. Once I do that, I can now pass in two blocks. One of them receive completion. So this will take a completion argument, and the other one receive value, which will take a value argument. So for the completion, this is an enumeration, so we can switch on it and get a case of the two different possible values. One of them can be finished, in which case this publisher is now done, or failure, which will give us our error type. And you notice that it said never there because we are working with a publisher that never fails, so we actually don't need to switch on this. We can just print it out so we can see it. And I'm going to do the same thing here, printing out the value from the receive value part of this. So now I have a publisher and a subscriber. To connect these two things together, we start with the publisher and say subscribe and pass in the subscriber. Now if I run it, you can see we get our output 1, 3, 5, 8, 11, and then finished. And all of that happened as soon as we subscribe to this publisher, because publishers will produce these values on demand. Next, let's take a look at the example. We're going to say sync example shorthand, let's call it, and we'll change this. So basically, we're going to do the same thing we did here, but we're going to do it in a more compact version that you'll probably see more often when dealing with Combine. So this is sort of the manual approach, and it's important to know that this is happening under the hood, but we don't always have to write it out like this. So I'm going to delete this code here, and we're just going to take our publisher, and I'm going to call sync on it. And notice that sync takes two overloads. One of them is receive completion and receive value, and the other one is just receive value. You can get this shorthand version where you don't have the completion if the publisher you're working with is a failure type of never, meaning you don't really have to handle the error. But if the failure type is anything other than never, you have to specify this one, which will give you both the error conditions and the values. So I'm going to do this just so we can match this up with what we had before. So here we had completion. We'll print it out. And then we have a receive value, and we'll print it out. So if we run this, we get the exact same output, and this is dealing with the shorthand, and this is basically how you'll be working with Combine most of the time, which is just chaining together things on the end of publishers. So let's take a look at the other type of subscriber that we were talking about, which is the assign subscriber. So let's create a assign example manual, that new example function. And now we're going to create a new publisher we'll call messages, and we'll call publisher on the end of that array. So now we have a publisher that produces strings, and the failure type is never. Now I want to have a class that we can work with here. I'm going to call this forum, and this will have a var for the latest message, and I'll initialize that to an empty string to start off with. And then I want to add a did set here that will print latest message is now. And I'm doing this because I want to know when we're setting this property. So let's create an instance of that forum. And now I want to create my subscriber. So this is going to be subscribers.assign. And subscribers.assign takes two generic arguments, but they're not the same as what we saw before. In fact, subscribers.assign takes the object that we want to assign to, so in this case, forum, and then the type of the property we want to assign, which is going to be a string. So under the hood, this is going to create a subscriber with an input type of string and a failure type of never. Assign always works with failure type of never, and you'll never be able to subscribe an assigned subscriber to something that can produce an error. You've got to handle that error first, which will transform the publisher into one that produces never, and then you can attach it to a assigned subscriber. Okay, when we open that up, now we have object and key path. I can pass in forum here, and then a key path into that property. So \dot latest message. So that is our subscriber. Now that I have the publisher and the subscriber and their types are going to line up, I'm going to say messages. So start with the publisher, call subscribe, and pass in the subscriber. And if I run this one, you can see that it set the property twice on our object. First one, when this publisher emitted this string, it assigned it to the latest message property of the forum object, and then again with this one. Okay, let's duplicate this example, and we're going to do it in the shorthand way. And we'll change this call down at the bottom. So now I'm going to start off with the same messages publisher and the same forum object. This time I'm going to delete that and just say messages.assign to on. Now this takes the key path first and the object later. And as you can see, there's a generic parameter that it doesn't understand yet because it's called root, and it doesn't understand it because I haven't told it what type of object. So if I hit tab and go to this one first and pass in the forum and then hit shift tab to go back to this one, sometimes it can be a little bit easier. And you'll get code completion sometimes depending on Xcode's mood. But basically now this is a shorter version of doing the same thing as before. So assign to this property on this object, and these things are now hooked up. And if I run it, it's running in the shorthand version and assigning the values coming out of this publisher to this property on the forum object. So I want to talk a little bit about what happens when you subscribe to something. So here I'm going to subscribe to this ints publisher using the sync subscriber. And we'll just print it out. So as you can see, this does work, but what we're doing here is we're sort of skipping an important part of this concept. And this is because The Playgrounds is executing this right away, and the values are already here. So as soon as we create a subscription, it emits the values and completes. But what we would find is if we tried to run this in some code where it was not receiving the values right away, it would just give up on the subscription because we're not hanging on to it in any way. So the subscription is actually the piece of the puzzle that you need to hang on to for this subscription to stay around. And so if we go back to that manual approach where we create a subscriber, which we'll use subscribers.sync, and we will sync to a type of int and a failure type of never, and then we can add in our receive completion, which I don't really care about, and then receive the value, and we can just do print $0. So if we think about this, and we take this and say ints.subscribe and pass in the subscriber, we need the in keyword there, and let's put these on their own line to make it a little bit easier to read. So we can see that this works, but we can actually call sub.cancel, and this is what's happening when this goes out of scope. It's calling cancel on the subscriber, which is in turn canceling the subscription, which is cleaning up all the memory used here. So if you were to use this in a real application and you weren't saving this off somewhere, your streams seemingly don't work. They don't really do anything, and that's because the subscription is getting cleaned up ahead of time. So what we need to do is kind of hang on to this for a while. And we've seen how we can call cancel on a subscription. But if we go back to that shorthand approach where we did inst.sync with the value and just print it out, this one returns an object called an anyCancelable. So we can see that this is a combine.anyCancelable. And so this is basically a type erased way to reach into that cancel and delete the subscription. But it's got an added bonus in that when it goes out of scope, so if we say var x equals the anyCancelable, and then later, the method that we're in or the class that we're in gets deallocated, this memory goes away and it will in turn call cancel on that object for us. So where this becomes useful is if you have a class, and I'm going to create a class called TikTok, and we're going to have an initializer that's going to set up a timer publisher. So we're going to say timer.publish every. We're going to say every half of a second, and this requires us to specify the run loop and the run loop mode. So for the run loop, we can pass in .main, and for the mode, we can pass in common. Now, timer is a specific type of publisher that you have to either call connect sometime, or you can say auto connect to start the timer on the first subscriber, which is what we're going to do. And then we're going to sync on this to subscribe to the value. And in this case, we don't care about the value. And if you remember from earlier, the value of this timer publisher is going to be the date. And so here we can say print tick. Okay, so now if I try to run TikTok, we'll notice that we don't get any output at all. I did create it. It created the publisher. We attached a subscriber to it, but then we didn't hang on to the result. So we can see that, we never got any of these timers. And if you're following along, just make sure that you've got this playground page.current.needs indefinite execution to true so that your playground doesn't stop at the very end of this. Okay, so what we need to do is hang on to that. So there's two ways to do that. One of them is I could say, here's my timer cancelable, and that is an anyCancelable that is optional. And then here I will say timer cancelable equals the result of this whole expression here. So if I've done that, then it's going to hang on to the subscription as long as this is active, which is going to stay alive as long as this class is alive. And of course, the class is not alive if we don't assign it to something. And now we've got our ticks. Okay, so let's add a dispatch queue.main.async after, and we'll do .now plus 4 seconds, and then we will set example to nil, which means we need to make this optional. And let's give us a little bit of a message cleaning up so we can see when we're actually going to set that to nil. And now we run it and we see tick and then cleaning up. So you can see what's happening, But if you want to get some more information about what's happening in a publisher, you can go back up here, and after the auto connect, we're going to type print. Now you can just do print like this and it will start printing some debug information, and you can also give it a prefix. So I'm going to prefix this with timer. So now when we run it, we're going to see some more information. So first, timer received the subscription. Then there's this request unlimited, and this is what's called subscriber demand. So basically when a subscriber subscribes to a publisher, the subscriber is going to demand a certain amount of values. It could demand a maximum of, say, 5 values or a maximum of unlimited. Most of the time it requests unlimited, but this is a mechanism for which the subscriber can be in control. So imagine you're a fireman and you're connecting a hose to a fire hydrant, and you want to be able to control how much water is being sent to you rather than being inundated with too much data or too many values that you either don't care about or can't handle for memory reasons. So this is called back pressure management, and it's more of an advanced concept. For the most part, you don't really need to know about it until you get into creating your own subscriptions in your own publishers. So that's what's happening here. So we see a request for unlimited values, and then the timer is receiving the value and it's sending it downstream, and we can see that as we go. So print is a really handy debugging tool, which can show us what's going on. And then when we said we were cleaning up down here, we set example to nil. So because example is set to nil, it gets deallocated, which deallocates timer cancelable, and then the timer subscription received cancel. So this is the mechanism of how this works. As long as this hangs around for as long as you need it to, your subscription will hang around. Now, I don't think it's a great approach to create a separate property for each of your subscriptions. And so usually you'll have a cancelables, which is a set of any cancelable, and you'll just initialize that to an empty set. And this can be, private to your class. And then instead of storing it manually like this, there's a handy store in, and you can pass in any range replaceable collection, but usually I use a set. So this ends up reading really nicely, and this is kind of the structure that I typically go with when using Combine. You start with your publisher, you add on your operators, finally your subscriber, and then you store it in cancelables. And if you try to use this in an app and you don't store it in cancelables, notice that you can see that it requested unlimited and it canceled immediately. And this is sort of the crux of the issue. And usually you'll get a compiler warning. It's probably because we are in a playground right now that I'm not getting a compiler warning, but typically it'll say, hey, you're not using the return value of this. And that is your indication that you didn't store the cancelable in the set. One thing I want to touch on here, let's say we wanted to do some more logic in here besides that. So I'm going to cut this, and I'm going to go over here to func tick, and we're going to put tick in there, and then I'm just going to call it from here. So let's run it again and see what happens. So notice we said cleaning up, and it's still ticking. So what's going on here? Well, what we did was we're no longer allowing TikTok to be deallocated because this timer publisher and all of its chain eventually gets to the sync subscriber, which retains this block, and this block is retaining self, which sometimes is fine, but if the lifetime of this thing is bound to the lifetime of the owning class, then you have a retain cycle. And because this will only go out of scope once cancelables goes out of scope, we basically have no way to break this cycle because we have this retain here. And we have two options here. We can use unowned self, which you have to be very careful about this, but this will work for you if you have this type of setup where it's impossible for self to ever be nil when you get into this block. And that is technically true in this example, because what will end up happening is we're not going to be retaining self anymore, so we broke the retain cycle, and it's not going to invoke this if it has been canceled. So the order of operations should avoid us from any kind of crash. So definitely you have to be careful with this sort of thing. If we run this again, then we should see that we have cleaned up that retain cycle and therefore cleaned up our subscription. This is really, really important. Okay, if you are not sure about whether or not it's safe to use unowned, because this is basically crash territory. If you ever entered this block, if there was ever a race condition between the timer firing and the subscription being canceled, and somehow the class was deallocated and it tries to call the tick, it's going to crash here. So instead, you can use weak self, in which case we can use self ? And safely call this if self is non-nil. And this is usually the safer approach, but I tend to use unowned if I know it is safe to do so. And so it also lets me avoid putting self dot inside the block, which is kind of nice. So definitely something to be aware of when you're doing combined publishers and you're storing the subscription bound to the same class. I bring this up about canceling and memory management and all this because a lot of the examples that we're dealing with inside of Playgrounds don't actually need to store these things because we're dealing with publishers like that int publisher or the sequence publisher that had the values already and they emit them immediately. And so even if you were to cancel immediately, the values were already delivered. And so really this is more important in the realistic examples where these values are going to be coming in over time and you need that subscription to stay active. And so as we do these examples, if we're running in Playgrounds, sometimes we're going to take the shortcut and avoid storing things in cancelables because it would be unnecessary for that example. But just know that once we get into live examples and real applications, we will be doing this everywhere. Subjects are a special type of publisher. So far in this course, we've seen a few different type of built-in publishers like just, empty, fail. We saw publishers.sequence when we were using arrays, and we saw timer.timer publisher when we were talking about the timer. And these are all built-in publishers that either have a value now or they know how to generate a value. So they are kind of intrinsic publishers that are built into Combine. But oftentimes you have some code or some events or values that are happening outside of the Combine world and you want to send them into the Combine world. And that's where subjects come in play. And there are two different types of subjects in Combine. There are the pass-through subject, and there are the current value subject. So we're going to talk about the pass-through subject first. So let's move that down. So we can define a subject like this. Create a pass-through subject and give it two generic arguments. These are the same generic arguments that you would use for the output type of the publisher and the failure type. So here I want to have an output type of strings and a failure type of never. And I can create it just like this. Now that this is a normal publisher, I can subscribe to it just like normal. I can say sync and either receive value or receive completion. And so here I'm going to print, and we're going to label our examples. So this will be number 1, received, $0. And now we subscribe to it. And remember that we're in Playground, so we don't really need to handle the cancellation that gets returned from this. It'll just work in the Playground because we're just running this from top to bottom straight through. So now that I have this set up, I've got a publisher and I've got a subscriber. Now I can tell my subject to send values through that publisher by using the send method, and I pass in the input. And notice that the input type has to match the output type. The compiler gives us this for free. And now we can send through message 1 and send through message 2. And if I run this, we see that we receive message 1 and message 2 in our subscriber. Okay, let's look at another example. So we'll add a little divider here. This one is going to be called subject 2. It'll be a pass-through subject that produces strings and doesn't fail. This time we're going to add a sync that has a completion and a receive value. So I'm going to put each of these on their own line. So we've got completion in, and then we've got value in. Here I will print 2, and then the completion object there. And here we'll print 2 and the value. So now I can send some messages through subject 2. This time I'll send testing completion. And then we actually have to tell the subject that it is complete. So here we can send the completion event. And notice the type here is subscribers.completion that is generic over the failure type that we're working with, which is never. And that means that although this enum has failure and finished, I can't use the failure one because the type is never. I have to use finished. And if we run this, we see that our second example, testing completion, and we get the completion failure. So subjects work just like any other publisher. We can also work with errors. So here, let's create another example. This one will be subject 3, pass through subject. And for this one, we want, again, an output type of string. And let's say we want to use our own custom error here. So to do that, I can create a my custom error struct that implements the Swift error protocol, and that's all we need. So let's just copy this one, change these to 3s, and now we're going to say subject3.send testing failure, and then subject3.send, and this time we will pick the completion.failure and pass in a new instance of my custom error. Okay, and we run that, and we can see that we get our message here, and now we get the failure completion event that has an associated object that is the actual error that we got. So this is how we're going to deal with passing through completion, errors, and values using pass-through subject. Now the other type of subject is current value subject, and this one you can kind of think of like a variable plus a publisher. So here I'm going to have a publisher called Word of the Day. And this is going to be a current value subject, and you have to specify the generic arguments just like before, so string and never. The difference here is that this has to have a value right now. Notice that the value is expecting a string. So I have to pass something. I can pass an empty string. I could, if I want to make my output type optional, in which case I could have a nil. That's totally fine too. But if my output type is string, I have to specify a string here. So let's say the word of the day is bellicose. So now we have word of the day.sync to add our subscriber, and I will just print the word of the day is $0. And if I just run it like this, and I forgot my divider, so let's add that back in as well. Notice that here we get the word of the day as bellicose immediately. So it had a value, and we subscribed to it, and it sent the current value right away. And this is very similar to what we saw with the sequence publisher. The array of values like integers would send the values immediately because it already had them. So in this case, current value subject will send its current value to any new subscriber. Let's add another word of the day. So we're going to send a value through this publisher, erudite. And if I run this, now we can see the publisher got the change just like before. So it's very similar, except we start off with a value. It also acts like a variable, so you can actually ask it for its value, and it'll tell you what the current value is at any time. Let's say we wanted to subscribe again. So I'm going to say word of the day.sync, and we'll print again, and this time we're going to print second subscriber received, and we'll pass in $0 like that. Now, if you notice, the second subscriber received the current value, but it didn't receive the first value. And that's because it only keeps track of one value at a time, and it's only going to send that value to new subscribers. But anytime after this, so if we say word of the day.send, and we pass in a new one, let's say cogitable, and we trick the playground into running, now we can see that both subscribers receive that value. So again, publishers can be subscribed to many times, and when you send a value through that publisher, all of its subscribers will receive that value. Now, the last thing I want to mention is that you don't always have a value to send. So let's say we had a button tap subject, which would be a pass-through subject. And in this case, we don't have a value, so we're going to use void there. So we can use void and never. And that allows us to say button tap subject.send with no arguments. And we can just send these events. And this is useful if you just care about the event that something happened, but you don't care about any actual data. So when would you use them? Well, subjects are a common way of gluing together existing code or APIs with combined pipelines. We're going to use them a lot in our examples to simulate sending events one at a time. You'll also use them a lot in tests, but for the most part, subjects are used to just bridge between the non-combined world and a combined world. Okay, so let's talk about operators. I mentioned before that operators are the lingua franca of combine. Using operators, you can transform streams into the values you want to work with, filter out the values you want to ignore, and more. The more operators you're familiar with, the more easily you will be able to manipulate a stream into giving you the results that you're after. Don't try to learn all of them at once. Not only will that be extremely boring, but you can get by with learning only a few of them. Over time, make sure you explore a bit and experiment with the other operators. There are a lot of operators in Combine. We'll start by introducing you to a few common ones that you'll use a lot. Over the rest of this course, we'll encounter more and more operators and explain them as we go. So I would encourage you to take a look at the available operators in Combine, and every once in a while, just go learn a new one and see what it can do for you. Often you'll find that some tricky bits of logic that you had in a previous implementation of a combined stream can be vastly simplified by leveraging an operator that does that sort of thing for free. You can also create your own operators to encapsulate logic that you want to reuse or just to make more readable. So the most common operator is map, and we're going to use that a ton in this course. So let's look at an example of map. Here I'm using this example function just to make isolating our examples a little bit easier. Let's say I have a publisher that has some numbers. So let's grab the first few bits of the Fibonacci sequence here, and I've got a publisher of ints. I can chain on the map operator, and I can produce a new value taking in the input from the upstream publisher. So each one of these that's going to be passed into here is an integer, and this works similar to map on any sequence in the Swift standard library, but this time it's operating on a stream. So the values I'm going to get out of this is going to be the individual values that that publisher is producing. So we've got integers coming in. We can take that integer and then say multiply it by 10. Then let's subscribe to this. We'll just print out the value, and we're going to run it. So here you can see we've got all of our values there. And this is this warning is telling us that we're not saving off that any cancelable. And just a reminder, because we're in Playgrounds and we're just exploring, it's not that important. It actually does just work. So we can squelch that warning just by using _equals like this. But in a real application, you need to hang on to this results somewhere so that this subscription will live on for as long as you need to use it. It's also important to note that sometimes we will comment out this last line here and then assign this to a variable. And I just do this so that you can see the result of this. So if I comment out the map, you can see that X is going to be the publisher that we just created, right? And if I uncomment the map, notice that now we still have a publisher. So map just basically transformed one publisher into another publisher. Map is producing a publisher that produces integers. And that's because the map block produces integers as well. And if I were to change this to say, take the result of that and convert it to a string, now this is returning a publisher that's producing string values. Now, it's important not to get hung up on this generic argument that has this array brackets in here. This is how it knows what type of collection it's going to be producing in the end. You could just as easily work with a set here. And if I change that and comment it out, notice that now my sequence is wrapping a set of integers. But the underlying output value of this publisher is this integer type. So let's undo that and back up a bit. So sometimes you'll see me do this where I'm assigning this to a variable temporarily so we can inspect the types, because the types are really important. And what we're really concerned with is what kind of publisher is this? What kind of output does it have? And what kind of failure does it have? Okay, we'll uncomment that and get rid of this variable. Let's add another quick example. 1, 2, 3, publisher. This time we're going to map this to a string value that says and then the $0 that comes in. We'll add a sync with print $0, and we get and a 1, and a 2, and a 3. So this is an example of map where you transform the values from an upstream publisher into some new value that you want to work with. Next, let's take an example of filter. Now, filter is basically going to evaluate these values. I'm going to copy this publisher here, and we're going to turn this one back into one that produces integers like this. So I'm going to chain on a new operator on the end of this. So filter is going to take values that this operator is producing. And what we're going to do is check to see if $0 is less than 60, then I want to allow it to continue. So if I run this again, we can see our example filter is only allowing the values that are less than 60 through the publisher. Now, it's also important to note that this publisher stream is still alive until the upstream publisher completes. So if we were to change this sync into one that says receives completion, and we print $0 and then receive value, and we print $0 again like this. So this one will actually see the completion event as well. And if we run it, you can see that it still finishes after it's received all of the values from the upstream publisher. It just filters out the ones we're not interested in. Let's take a look at another example. This time we're going to use the scan operator. Now the scan operator is very similar to reduce in the Swift standard library. You can take basically a collection of values and sort of distill them into something new, something different. Like if you think of map as being kind of a one-to-one transformation, you take an array of 3 values and you map them, you're going to get an array of 3 values back. And same thing with streams. If you have a stream with 3 values and you map that stream, then you're going to get 3 values back. Scan is kind of similar in that you're going to get values as it's working, but it also allows you to sort of accumulate values over time. So here's an example of, say we're taking keyboard events and we're basically typing 1 letter at a time. So here we've got 3 sort of individual keystroke events that are being turned into a character or a string in this case. And so now I've got a publisher of type string. I'm going to call scan on this, and scan takes an initial result, which is a t. So this t is up to us right now to define. I'm going to say that I want to produce a string, and I'm going to start with an empty string. Next, I'm going to hit tab and then enter to expand out this block. This also gives me the t that we use over here. So this is the accumulated value, and sometimes I will call this accumulated. And then finally, this is kind of hard to read, but this is basically saying whatever the output of our publisher, upstream publisher, that's going to be the variable type that we're using here. So this, in this case, is going to be some character. And then I need to return that t that we defined here. So I need to return a string from this. So here, I need to return whatever the new accumulated value is going to be. So I'm going to take that previous accumulated value and append on that character. Now I have a publisher that is producing strings. So I can sync and receive value on this. We'll print $0, and then I'll squelch that warning. And when we run it, we can see the individual accumulation of the word that I'm typing. Let's take a more complex example of scan. So let's say I have some grades, and grades is an array of doubles. So we've got 98, 65, 49, 99, 100, and 95. So those are the grades. And I want to get a publisher of those grades. So now I've got a publisher of doubles. I'm going to call scan on this. And my goal here is to get the running average of all of these things. So one way I can do that, you might think that I want to start off with an average of, a double value here, but I actually need to count this total sum. I need the running sum, and I also need the running count. So I need a few different values, and for that I can use a tuple. So I'm going to say tuple, the average is 0.0 to start off with, the sum is 0.0 to start off with, and the count is 0 as an integer to start off with. So that's going to give us the tuple as the accumulated value inside the block, as well as the upstream value, which is a grade. Then I need to return a new instance of this tuple type, and I can actually omit it here because the compiler will be able to infer this when I'm done. But this brings up an interesting point. Sometimes the compiler will get confused, or it will give you an error that doesn't quite make much sense, and you can often help the compiler along by specifying all of the types here. So if you run into a situation where you're getting kind of a puzzling error message, sometimes you can try to explicitly type out the type that you're returning in all of these operators, and then it will often point to the actual error that you are encountering. Okay, so what I need to do here is I need to take and calculate a new sum, which is going to be the previous sum plus that new grade that just came in. We also need the count, which is the previous count, plus 1. And then we need the new average, which is going to be that new sum divided by double count. Finally, I can return a new tuple that matches the type that we're supposed to be returning here. So we need the average, we need the sum, which is our new sum, and we need the count, which is our new count. So now if I take a look at this publisher, notice that this is now a sequence publisher, but the type that we're getting is this type here, which is our tuple type. Once that's done, each step through, I can map that tuple type and say, I don't care about anything else but the average. So scan allows us to kind of maintain the state through this accumulated type here and roll up whatever values we want, and then we can just map those and pull out the value that we're interested in. So we now have X is now transformed into a sequence publisher of doubles. And then finally we can sync and print out the average. Okay, let's run that. And we look at our scan results, and we start off with an average of 98 because that was the first grade we got. And then we got a 65, which brought our average down to 81.5, and then so on and so forth. And our final average is 84.3. So that's an interesting example of using scan. Again, it's very similar to reduce in the standard library. Here's one more example. For this one, we're going to create a timer, and I want to publish every second on the main run loop in the common mode. And as I mentioned before, timer is a special type of publisher called a connectable publisher. And there's not that many of these, but pretty much every time you use timer, if you want to start as soon as you subscribe to it, you're going to use AutoConnect. So that's just something you have to remember when working with timers. And now I want to take that timer and I want to call scan on it. What I want to produce here is a timer that counts up from 0. So we're going to start with 0. Then we're going to get our count. And then this is the timer's output, which is always a date. But I don't care about the date, so I'm just going to use underscore there. And at this point, I need to return t, which is another int. And like I mentioned before, you can often simplify these things, but I would only advise this if you're doing something simple and the compiler can figure it out. So at this point now, I just need to return count plus 1. So this accumulated value is going to start with 0, and every time timer emits an event, we're just going to add 1 to count. At this point, now we can call sync, print that output, and this is an interesting case because we need this playground to stay around for a bit. So we're going to set playground page.current.needs indefinite execution as true. And we also are going to turn it off. So we're going to do dispatch queue.main.async after. So we'll do after 3 seconds, we will turn this back off. And then I need to hang on to the subscription because we're doing something where we need it to, live for a bit. So we're going to call this the timer cancelable, which will be an optional any cancelable, and we'll set that equal to this whole chain here. And then inside the block here, we can cancel it. Okay, now the playground, the way I've set this up, this is actually a warning that we can kind of ignore. Let's just go ahead and run it and see if we get our timer. And now we've got a timer that counts up from 0 as long as it's alive. Okay, so that was scan. Let's take a look at a couple more. We're going to look at remove duplicates. And remove duplicates is pretty simple. Let's say we have some values here like this, and I create a publisher of those, and I say remove duplicates. Now the upstream value has to be equatable for you to get this one that just works like this. But if it's not equatable, you can pass in a block here and provide the sort of equality comparison or the duplicate detection logic yourself by passing in a block. But in our case, we're just concerned with the equality comparison. So we say remove duplicates and then sync print $0. And now when we run remove duplicates, notice that we no longer get that sequence, that series of ones. We only get 1, 2, we get 1, 3, etc. But it doesn't remove them from the whole chain. It only removes them as long as it was different from the last one received. So that can be really handy in our example where we talked about search. We wanted to avoid searching for the exact same term again. So remove duplicates is really useful there. And there's one more example I want to cover in this video, which is compact map. And compact map, again, works very similar to how compact map works in the standard library. Let's say we have a values array, which is optional integers. So we've got 1, nil, 2, nil, and 3. And then I can get a publisher of those values by saying values.publisher. And here our publisher type is producing values that are optional ints. And if we don't care about the nils, it kind of stinks to have to work with those. So what we can do is compact map that and pass in $0 as the value that we want to use. And if the value returned from compact map is nil, then it'll just ignore it. So now if we look at our publisher type, now we have erased the optional. And so we can sync print $0. And now we only get 1, 2, and 3, but none of the nils. And of course, our timer is still firing. Where this might be useful, let's say we had some user input, and let's say we had some values that are coming in from a form. We have a text field or whatever, and the values coming in are integers, but they could be letters as well because it's a text field, right? And so we can't really trust that the user is typing in integers all the time. They might be typing whatever. So here I've got a publisher of strings, and I compact map this, and the value I return from this is the integer initializer that takes a string, and this integer initializer can fail. And if it fails, it returns nil, which compact map will then strip out. So if we look at our publisher type now, we've got a publisher of ints, which is what we wanted, and now we can subscribe to it. And this is the output here. Okay, so that's a quick look at some common operators you're going to use a lot. So I want to cover some more operators in this video, and the operators that I'm going to cover now are all operators that may wait a bit and collect some values before they actually emit anything downstream. And the first of those I want to show is an example of a reduce. Now I mentioned last time that reduce, or rather scan in Combine, is very similar to reduce in the standard library, with the one exception that it continues to send values as it receives them. It just also allows you to accumulate sort of a running total or some sort of result. Reduce is different. So if we have your grades here in reduce, and I'm just going to make a sum version just to make this a little bit easier. So we'll have values is 1, 5, and 12, and we can get a publisher for that, and we can call reduce. And here we start with the initial result and the next partial result, just like we did before. So this would be the sum and then the value. And here I need to return an integer. And so here I'll just return sum plus value. And what I'm going to do here is just print. So we can see the values here coming from this publisher. And then we're going to sync and print out the final value that comes, or any of the values that come out of the reduce operator. So notice that in the print statement, we received those 3 values, and reduce is just sitting there waiting. It's collecting all the values, and it's waiting to see when the upstream publisher finishes. And when it does, it emits its final accumulated value. So that's the difference between scan and reduce. One of them will allow values through as they happen, and one will wait for a finished event. So it's a good thing to note that some of these operators are going to sit there and wait for the upstream publisher to finish. Not every single upstream publisher will even finish. Not all of them can. For instance, timers, they'll just fire forever until you cancel them. So some of them may never finish. If you've got a button tap publisher and you're waiting to count how many button taps there will be, you're going to have to at some point tell that to complete before I can tell you what the count is. And speaking of count, there's an example of that we can talk about. Let's say we do kind of a similar thing here. And instead of reduce, this time we might say count. And again, it's very similar. It waits to see a completion event before it tells you how many there are. And so there's lots of examples of these. There's last, which again, if I say I want to get the last value, it has to go through them all before it can tell you what the last value is. Now, if you contrast this with first, which is another operator, so let's add first here, and this time I'm going to say first. Pay attention to what happens here. first gets its value, and actually I want to put first here instead of last because I overwrote my print. So let's run that again. Notice that we received a subscription, we requested unlimited, we received the value 1, and then it canceled. So what happened is this stream here, the operator first got its value and no longer is interested in anything else because it knows it doesn't need to handle any of them. We just wanted the first one. So it ends up canceling the upstream publisher to avoid any further work from being done. And then we print it out. So first is kind of interesting because it knows it can bail out early. Let's do another example. This one is output at. And output at is kind of like indexing an array. So here we can say output at 2. Then in this case, kind of similar, we've got our subscription, 1512, request unlimited. We see the first value and notice that output is saying, yep, keep going. So notice that it's saying this request max and request unlimited, these are the demand things that we talked about. And we'll get into this more a little bit later. You don't really need to know so much about this, but basically it's just telling us, yeah, give me another one and give me another one. And every time it receives the value 5, then it receives this one, and now it's got the answer, and so it says, okay, go ahead and cancel. Now that happened to be the end of that publisher up here anyway, but if I added some more numbers to the end of this, you'll see that none of those values were produced by the sequence publisher because by the time it gets to 12, we're at that index and it just gives up at that point. So this is something if you need for whatever reason to get the third value out of an array, you can do it with output at. Then there's some others that I think you should experiment on your own. There's max and there's min. Those should be fairly straightforward. As long as your values in your publisher are comparable, you can get the maximum or the minimum. And again, these will wait until it receives a completion event from the upstream publisher before emitting the value, because otherwise it can't know the answer. And then finally, I want to talk about collect. So collect allows you to take values that are being sent down a publisher and then collect them into an array. So here it's going to take an array, turn it into a publisher. It's going to emit each one of these values. Then it's going to collect all of those. So it's going to sit and wait here until it gets a completion event. And all of the values it received are going to be returned as an array. So we're going to get one single result at the end that gives us our array. So it's kind of interesting. We started with an array, then it kind of opened it up and fed each one through the pipeline, and then collect allows us to collect it back into an array again. So these are some examples of operators that can sometimes sit and pause and wait for a completion event or wait for a specific index before it can actually continue. So sometimes, if you're working with a publisher that isn't completing, then these will just sit there and not produce any output. And sometimes it can be a little bit hard to tell what's going on. So it's good to know that this can happen. Okay, let's take a look at some operators that work with multiple streams. So the first one we're going to look at is called merge. Now, merge is pretty easy to understand. Let's say we have a publisher here that is a current value subject of int and never. And because it's a current value subject, I have to give it a value now. And let's add another publisher, and this one's just going to be one that produces a few numbers right away and then completes. So now I can create a merged publisher, which takes pub1 and merges it with pub2. So the type here is a little bit unwieldy, but you can see that the type is publishers.merge, and it's got two main sections. It's got this current value publisher type on the left, and then the other publisher type on the right. And we're going to talk about how we can work with types like this, because this is really cumbersome and you never really want to write this. But we, for the most part, don't really need to deal with it. We just use it, right? So we can kind of view this as a simplified version of, both of these are publishers that produce ints and have a failure type of never. And so that's the same as our merge type is going to be. So if I say merged.sync and I do print $0, we get the first value from up here, because this one was a current value subject and it was first in this list here. So it gets this value first, followed by all of those. And then if we decide that we want to send more values in to pub1, and I'm using hundreds, so it's a little bit easier to see. You can see that just sort of get merged in at the end. So downstream, this subscriber, the sync subscriber, doesn't care what's happening upstream. It just knows it's got a single publisher that it works with that's producing ints. It's also worth noting that because this one completed, right, this one sends a finished event, but merge does not. And we can see that if we use print here. So we can see, it got to the end and canceled because all of these things are getting cleaned up because we left this list here. But you can see that the merge never got the finished event. And that's because pub1 is still alive when it got deallocated, right? And when you get deallocated and you haven't sent a completion event, it will just cancel the stream. It's not going to finish it for you. So we would have to send pub1.send completion.finished. And if we do that, now both of merge's upstream publishers, which is pub1 and pub2, both of those have finished. And so merge has no more work to do, and so merge can finish. So that's an example of using merge. Let's take a similar example. This one is going to be merge multiple. And so in merge multiple, we're going to have pub1, which will be 1, 2, 3 publisher, pub2, which will be 4, 5, 6 dot publisher, and then pub3, which will be 7, 8, 9 dot publisher. So we can take pub1 and then merge this, and notice that you've got merge with, and you've got all these overloads that take different amounts of them. So you could say, okay, I want to merge this with 3 others, or maybe just 2 others. And that does work. I could say pub2 and pub3. The thing that I don't like about this is it kind of mixes them when they're all upstream publishers to the merge operator. And so another way to write that is to create the publisher class itself. In this case, we can use publishers.merge3. And you can see there's types for each of the different combinations, but publishers.merge3 is going to take exactly 3 inputs. So we can pass pub1, pub2, and pub3. So the style really doesn't matter if you use the one where you're chaining together operators. Sometimes that's more readable. Sometimes this makes more sense. So we've got this merge3 publisher, and now we can sync and print $0, and now we can get the merged result of all of those publishers. And then finally, there's also merge many, and here you're expected to pass in an array of publishers. And if you do that, it does the same thing, but it doesn't matter how many publishers you have. It's just going to join them all together, and whatever values come in the order that they come in are going to be sent downstream. So merge is really useful as long as the values that you're getting from each of your publishers are all the same. It's not just the output type, but the failure type, they all have to match. So if they don't match and you still want to combine 2 different streams, for that, you're going to use probably zip. And zip is, we talked about this a little bit when we were talking about marble diagrams, but basically it takes 2 different streams and sort of pairs up the items together. So let's say we've got ints, which is 1, 2, 3, and we've got letters, which is A, B, C, and D. Here we can say ints, and of course we've got to turn both of those into publishers. So we can say ints.zip with letters, and now I have a publisher that is going to produce tuples, and the type of the tuple, it's going to have 2 elements. The first one's going to be an int, the second one is going to be a string. So here we can say map that, and this is one of those cases where the compiler may figure it out or it may not, but I could do $0.0 to get the integer portion of this because that's the left-hand side, and then the right-hand side would be .1. Sometimes this can be a little bit hard to read. But here I'm going to just come up with like a string format that uses both of these pieces of data, and we'll use $0.1 there. And then let's say we sync and print $0 here. So you can see that 1 got paired with A, 2 got paired with B, 3 got paired with C. Now, what happened to D? D is ignored because this stream completed. So basically, zip is going to wait for values from both of the streams before emitting an event. So it got one from the left-hand side, and it's waiting for one from the right-hand side. It gets one from the right-hand side, and finally it emits that value. So if we were to do this manually by using subjects, you would see that the sending one event doesn't necessarily do anything. Zip is still waiting for the paired event. And this isn't just limited to 2. We also have kind of a similar thing where we can zip with multiples. And here, this is one that takes 3 additional publishers to zip together. And in addition to that, we have the ability to use the publisher type itself. So we can use publishers.zip. And notice we've got zip, which is, inherently just 2 elements, zip3 and zip4. And it's worth noting that because what you get downstream is a tuple, working with more than 4 elements is really cumbersome. And if you really, really needed to, you could have a zip with, A and B, and A is actually a zipped publisher of 4, and B is also a zipped publisher of 4. So that would give you, 8 possible values. And you would have, in order to read values out of this, you'd have to say, okay, $0.0, which would give you A. And then I would need to say .3, which would give you the 3rd element out of this one, which, this is really not fun code to write or to read, but it's possible you could do it that way. But I would say if you're trying to do stuff with more than a tuple of 4 values, you probably want to rethink your design anyway and maybe choose a different tool, but it is possible. All right, the next example I want to cover is combine latest. Now, combine latest is similar to zip, except it will wait to make sure it has a value from each one of its upstream publishers, but then it doesn't necessarily pair them up together. It just always gives you the latest set. So let's say we have 3 light switches. So I'm going to call this pub1, which is a current value subject of type bool and never, and it is currently off, so we'll say false. And I want 2 more of those. So these are just modeling 3 light switches. And I only want to continue and perform some work if all 3 are on. So if I use zip, it would only give me the pairs, or in this case, the trio or the triple of the values. And that doesn't really help us because, pub1 could be turned on, and then I need to go reevaluate all of them again. And so this is where combine latest is really handy. So I could say pub1.combine latest, and then I can pass in another publisher, in this case pub2 and pub3. So this would let me combine the values of all of these. And again, you can use publishers.combine latest, and you've got this one which takes 2, this one which takes 3, and this one which takes 4. Here I'm going to use combine latest 3. So I need to pass in pub1, pub2, and pub3. And here we're going to print this out. I'm going to call this CL so we can see it. And then I want to map this. So this is going to be all of our switches. And switches is going to be a tuple with 0, 1, and 2 in it. So I just want to say switches.0 and switches.1 and switches.2. So what this is going to produce is a single Boolean, which tells me if all of them are on. Then let's say I want to filter out any and only get true values downstream. And then finally, we can sync and print $0, or rather here, I don't really care about the output. So I'll use the _in and I'll say, okay, ready. So this means that all 3 switches are on and we're ready to continue. So in this situation, what I can look at, if we run this, notice we started all of them at false, but then I set this one to true before we created this publisher. So what we're seeing here is we got the subscription, it requested some values, it received the first set of values because all of its upstream publishers all have a value already, and that's true, false, false. So at this point, the cancel is because we left the method, but if I want to continue on, so here I want to say pub2.send, and this time I'm going to send pub2 to be on, and I'm going to print out a value setting pub2 to true. And if I run this guy, now we can see setting pub2 to true, received a value, and now the print statement is seeing the value true, true, false. So it emitted a new tuple with 3 values in it with the current state of all, or rather the latest state of all of its upstream publishers. So it doesn't have to be a current value subject. It could be any kind of publisher. And combine latest is going to remember the latest value received from each of its upstream publishers. And then once they all have, or anytime any of the values change, it's going to emit a new event that tells us the current state of all of the publishers. So now I can say, let's set pub3 to true. And now we can see we got true, true, false. Then we set pub3 to true, which is going to emit another event with the latest value from all three, and now we're ready. So combined latest is actually really useful, and this is what I tend to use when I need to gather some input from a form. And the form is going to have some requirements to say, okay, well, the username's got to be present, and they've got to check this box before the submit button can be pushed. And so basically combine latest can combine the state of all of these different UI elements, and then you can make your decision in one place. Okay, let's talk about two slightly more complicated operators, but they're very central to how combine works, and that is flatmap and switch to latest. These both are in the same category in that they operate on streams that themselves produce new publishers. So as an example, let's look at this list of URLs that we have here, and we're going to create an example of flatmap. And then inside of here, let's use urls.publisher. So now we've got a publisher of URLs. And if I map this and I use URL session shared data task publisher for that URL, and we're going to talk a lot about networking later, but basically this allows us to use combine to deal with our networking, which is fantastic. So this is going to return a publisher for that URL. Now, in order for us to work with this and not have to deal with errors, the failure type of this publisher is never. And I also want this one's failure type to be never, but it is not currently. So we can use assert no failure, which will end up crashing if we get an error, but the publisher return from this will have a failure type of never, so it becomes easier to work with in this example. So if we take a look at the results of this, we can see that this is a publishers.sequence, but notice if we sort of zero in on the value part of this, notice that this is a sequence that is itself producing publishers. So it's a publisher of publishers. Now in the standard library, if you have situations like that, like if you have an array of 1, 2, 3, or you have an array of arrays of values like that, this is sort of a case where you might want to use flatmap, which can help flatten out this array, because basically this is an array of containers and you sort of want to unwrap it and flatten it. So the notion of flatmap, it comes from functional programming, and it doesn't necessarily have to do with arrays. It has to do with these container types. So in the standard library, you can flatmap optionals to sort of unwrap optionals of optionals. So the main goal is for us to sort of avoid getting a publishers of publishers, and instead downstream, I want a publisher of whatever this thing returns. So this is where map doesn't really work here. We want to use flatmap. Now, flatmap is going to take whatever input is coming from the upstream publisher, pass it into here, and then subscribe to this thing. So downstream, I'm just dealing with whatever output type this thing gives us, which is a tuple of the data and the response that came from this. So what we can do is use sync, and we're going to get data and the response, and I can then print out received data.count bytes from, and then pass in response.url. And URL is optional, but I know it's always going to be there, so I can force unwrap it here. Now, because we're doing some asynchronous work, remember we have this playground page, current needs indefinite execution set to true, and then I need to store this somewhere, so I'm going to store it in the cancellables set that we have at the top of the file. So I'm going to get rid of the X here. Okay, so next, before we run this, I want to explain one more concept here. Flatmap takes a max publishers. And I want to talk about this a little bit because it's important that we understand how max publishers work. So this takes a subscribers.demand option, and I can pass in none, unlimited, or max. So let's say that I only want 2, I want a maximum of 2, and this will become apparent as we run the example. So I'm going to run the example flatmap, And what we're going to see is that we received data from all three of these sources. Now, the order, they're out of order because this is networking. And you can see that, I started requesting this one first, but actually Apple was the one that arrived first. So that one, gets sent downstream. Okay, to zero in on exactly what's happening here, we're going to add a few print statements. First of all, we're going to print URLs on the URLs publisher. Now, what's good about print is that it's going to essentially be a pass-through operator, and we can add it in any part of the chain and give it a prefix so we can see what's happening. And then I also want to do another print statement after the flat map. Now I'm going to run this example and we're going to get a lot of output, and let's just see what happened here. So scrolling back up to the top, the flat map publisher receives a subscription from Sync and requests unlimited values. That's normal. Then this guy subscribes to the upstream publisher, which is URLs, and URLs receives its subscription and it has these values ready to send it. But URLs receives a max demand of 2, and that's coming from here. So URL says dutifully, I will honor your demand and only send you 2 values. So it sends the first 2 values from the array. Now, FlatMap is subscribing to the publisher that is returned from this block here. And FlatMap receives a value from apple.com in this case. And you can see the headers and all this other stuff that comes down. And then it sends it to the sync block and says, I received this many bytes from apple.com. Okay, so meanwhile, the combine Swift request is still in flight. But because FlatMap has essentially finished with and released this publisher, it now has a free slot to fill because we said a maximum of 2 at a time, and I'm done with one of them. So it then requests one more from the upstream publisher because that's how many we have a room for. And the upstream publisher says, okay, here's twitter.com. And now URL says, I'm done. I have no more content, so it finishes. Now FlatMap starts receiving the data for the combined Swift request. And if we scroll down, we can see that now we get the sync call, which prints out that we received the data for combined Swift. And then FlatMap receives the final one, which is twitter.com. And down at the bottom, we see that twitter.com is finished. And then FlatMap says, okay, I'm now done because there's no more content from the upstream publisher because it finished. Now I can finish. So again, FlatMap is confusing, and it's okay if this doesn't make sense at first. So just to drive the point home, let's take a look at this in another way. So let's say we have some input, and this input is a publisher, and it doesn't matter what it is. It's just a publisher of stuff. Now that input is going to send its values to FlatMap in this case. So we have FlatMap. This is an operator. Now the FlatMap operator is going to take whatever input it is. And so say, we get some input and it's going to do some work and subscribe to the publisher returned from the FlatMap block. And then when it's done, it's going to return back and send that down to, in our case, the sync subscriber, which will print it out. Okay, so I'm going to switch colors here so we can see, let's say we just have some value coming in. I'm just going to say 1. 1 gets sent over to FlatMap. Now FlatMap subscribes to the block returned and does its work for that value and then sends the result of that back down to sync. Now at the same time, it's also receiving the value 2, and because it has a free slot, it also subscribes to the stream for 2, does its work, gets the result, and sends that result down to sync. So as you can see, FlatMap is allowing work to happen in parallel, and it's subscribing to every publisher that is returned from that block. And the way that we can control how many are happening at a time is with the max publishers. In our case, we said 2, so it's only going to allow 2 publishers to be subscribed to, and as soon as a free slot is available, it will request more from the upstream publisher. Okay, now that we've seen FlatMap, let's comment out this example. We're going to do essentially the same thing, but with switch to latest. So here we're going to say example switch to latest. We're still going to start with the same setup here, but instead of flat map, we're going to go back to map. So we are now mapping to some publishers. So the results of this right now is a publisher of publishers. And that is the perfect input for switch to latest. So switch to latest is essentially going to read the latest value received from the upstream publisher, and that value is itself a publisher. Switch to latest is then going to subscribe to it, and then send the results of that latest publisher downstream. Now, if it gets another value, it only cares about the latest one, so it's going to cancel any previous publisher that it was subscribed to. So if we take a look at this example with switch to latest, and let's run it, example switch to latest. And we have a lot of output because of those print statements, but let's examine it. Switch to latest receives its subscription from our sync subscriber. That in turn subscribes to the upstream URLs publisher, requests unlimited values this time. And this is because it doesn't care how many there are, because we're only ever going to be concerned with one at a time. But as a new result comes in, we're still interested in that value. So URLs is getting all the values from the array, one at a time, and then URLs finishes. Switch to latest receives that first value. This is from twitter.com. And what's happening here is we only see the result from twitter.com. And the reason is that was the last value received here. But it is important to note that we can also add a print here, and we'll call this fetch and pass in that URL so that we can actually see it in the list, and we'll actually see what's happening to this publisher. So let's run the example again. We're going to get even more output this time. Let's scroll back up. URLs receives its subscription, and URLs emits this first value, combined Swift. That was the first one in the array. Now we're in the fetch part. Fetch receives this subscription from DataTask Publisher and requests unlimited values from that. So at this point, the request is being made. Then URLs, because it has a value again, it has another value, it emits the next value immediately. And switch to latest is saying, oops, we need to cancel the request for combined Swift and instead subscribe to the apple.com one. Then URLs emits a third value. Again, this is happening pretty much instantaneously because it's an array and it already has the values. It's just going to emit them one after another. So switch to latest says, oops, I need to cancel the apple.com request, and now I want to subscribe to the Twitter one. So switch to latest is ensuring that we only care about the latest value received from the upstream publisher, and we subscribe to the result of that. So it allows you to take one publisher of values, stitch it to another publisher that is going to do some work, and only get one result back. And this is really useful if you're dealing with things like, the user taps on one button and then they change their mind and they tap on a different button. And if we don't care about the results from the first button tap, then we should be using switch to latest because we only care about the latest, user action or the latest user input. So that's a look at flat map and switch to latest. These are complicated concepts, but they are central to how Combine works. So let's talk about type erasure. Now, on the surface, type erasure can sound like something that, language people care about and is kind of advanced. And in practice, it's going to really help us a lot to embrace type erasure when we're using Combine, just because of the way the compiler works and the way that Combine was built that leverages the type system heavily, but often we don't care about the specific types involved. We want sort of the generic abstract, things that we want to work with. And so far I've been talking about publishers in terms of those concepts. The publisher has an output type and has a failure type, and that's really all you care about when you're using it. So what I want to explore here is, let's say we have this publisher, and right now it is 123.publisher. If I print this out, we'll see the type that this publisher is. Of course, it's not called X, it's called publisher. And this is a sequence publisher whose generic arguments are array of int and never. And again, sequence publisher, the actual output of that is going to be this guy in the middle of this. And that's pretty easy to understand. What happens if we map this and say times 2? run this again, and we see it's still an array event. So that's fine. But what happens if we merge this with another publisher, say 456 publisher? Now, all of a sudden, we have this publisher called merge many, which has as its first generic argument this publisher type here. And, you know, it's a little bit more complicated now. Okay, let's say we're going to add some more requirements here. First, I don't care about the first value for whatever reason. So drop first is an operator that's just going to skip the first element and emit everything else after that. So I run this again, and now I've got a drop as my first, class here. And then inside of there is, some more generic arguments, and it's starting to get really hard to read. Let's say we also want to prepend to this list, some content from something else. Okay, so as you can see, we're using just some friendly operators. We're, transforming the stream of numbers into something else that we want to work with, but the types are getting really out of control in terms of having to look at this as a human and understand it. Now, when you're using them just in line like this, it doesn't matter, right? We're not really concerned with the actual concrete type. And where this becomes problematic is, let's say I wanted to take all of this logic and put it into a function, and this function is just going to be my number publisher, and I'm going to put all of the stuff in here. Okay, so now I want to call my number publisher to get at it. Now, what does this need to return? I say return publisher, and now I can say, okay, what am I returning from this? Publisher itself is just a protocol with associated types, so you can't return it like this, right? You need to have a concrete version of this that provides that output and failure type so the compiler knows what we're returning. So really, there's not anything that I can return from this that is helpful, right? So if I say return string just to get a compiler error message, it's going to say I can't return this to type string. So I'm just going to copy that and paste it right here. So that's my actual type here. And let me get rid of this last bit. That is my actual type that I'm returning. And now it compiles. But nobody ever wants to write this. In fact, if I decide that I no longer need to drop first from this, now the type for this method has changed. And so now it can't convert this thing to, whatever now the type is. And so this is a problem. And the reason why type erasure exists is because this is an implementation detail, right? Combine is built leveraging Swift's type system extensively, and it does this for good reason, right? You can, write extensions on any of these types to work with specific publishers to, customize behavior or to add your own operators or whatever. But these are implementation details, and we don't want to leak these implementation details to callers who don't know or care. We don't want them to have to recompile because I decided I no longer want to drop the first element out of this stream. So what we can do instead is use any publisher. So we're going to use any publisher as our return type. And to actually return that, we have to call erase to any publisher. Now, any publisher is a generic type, and so I have to tell it what type of values are we going to send and what type of error is this going to produce. So this has to line up with what we're working with. So if I run this, now all of a sudden it compiles and I don't have to specify these types anywhere, right? I'm free to change my implementation. The underlying types at work in the middle of the stream are preserved, but callers who use this deal with a generic bland version called any publisher because they don't need to know or care. And this is really important because this simplifies the interface. We'll use erase to any publisher in a lot of places just to make sure that we have consistent return values between maybe two different branches of code. Maybe we've got one that makes a network call to get some data and one that reads data out of a cache, but the underlying method needs to return a publisher of data. Well, we would erase both of those to an any publisher so that we have a consistent return value. So lastly, I want to mention, if you're familiar with Swift UI, you might be tempted to use some publisher as a return value. And Unfortunately, this has some drawbacks that make it a little bit difficult to use. So it is tempting to use, and if I run it, it does compile. And you can see that I get back, well, let me get rid of my erase to any publisher. So I'm returning the actual publisher. And, if we print this out, or let's say let pub equals that and print out pub, you can see that, when I print it out, it does print out the actual type, right? But if I'm holding down Option and I click on this, the type of this variable is actually some publisher. It doesn't know. And so where this breaks down is if I have, say, another publisher that also happens to be a publisher with an output type of int and a failure type of never, and I want to say pub2.merge with pub, this should work. But unfortunately, it doesn't, because it's saying I don't really know. Some publisher has an output type, but I don't know what it is. Even though under the hood it does, it's making it an opaque return type, which means that the compiler can't look into it and see the associated type requirement of output and see that it matches. And same thing for failure. So while it does compile, in practice it becomes impossible to work with, because the compiler can't basically guarantee that the output type is int and the failure type is never, and so working with it becomes really impractical. So in this case, we really want to just stick with any publisher of your output type and your failure type, and then just make sure to call erase to any publisher at the end of the chain. Swift 5.1 introduced a special property wrapper called @published. Using this, we can easily expose a combined publisher for a property whenever it changes. So here's an example. Let's say we have this car type, and it's got a private set variable called gas level. And it's got a drive function, which will check the gas level. And if we have gas, we'll drive, and then we'll remove some of the gas. Otherwise, we'll print out of gas. So if we scroll down here and we create a car, and then we just drive a few times, and I run it, you can see that we've driven. And if I drive one more time and run that, now we're out of gas. So it would be nice to get some sort of early warning to know that we're about to run out of gas. And to do that, I'm going to mark this property with @published. Now, using @published requires this to be a class, not a struct. But once we've done that, we'll scroll down here to where we're using car, and we'll say car dot, and note that we have our gas level property, which gives us read-only access to this gas level variable, but we also have $gas level, which is exposed by the property wrapper, and this gives a published value. So this is a published property wrapper's publisher, but it's basically a publisher of doubles. So I can use $gas level, and we can call sync on this and print out the value. But what I'd really like to do is use drop while, and that's going to take a condition. So this is an operator that will take in our gas value, and I can say drop while the gas in the tank is greater than 0.4. because maybe I'm not concerned with this warning until this happens. And then we can say, warning low on gas, and then pass in $0 so we can see the actual gas value. So now if I run it, you can see that when I get towards the end, it's saying warning low on gas. I have a quarter of a tank, and now I'm empty. So what's interesting about this, first off, drop is kind of similar to filter. But filter will always evaluate. And so basically it allows you to filter out any events that, that you don't care about. And drop is kind of like a one-time latch. It's going to monitor this block through every event or every value that gets sent through it. And as soon as this block evaluates to false, it's going to essentially throw this latch, and now all the events you're going to receive downstream. So it's a one-time latch, and if you later fill up, you're still going to get these messages. Sometimes this distinction can be really beneficial, and other times not, but it's worth noting that this operator is here. So the other thing to note is that we have now subscribed to this. So this is returning an any cancelable just like before, but because we're in our playground, it'll work if we ignore that value for now. I also want to take a look at another example. Let's say we have another private set var gas gauge, and this is going to be a string, which I'll set to be an empty string. And I want to have this gas gauge be in sync with this one. And so I'm also going to make this a published property wrapper, because I think that this is something that clients may want to react to as well. So now I can subscribe to the gas level publisher, and we can map this to the percentage as a string. So I'm going to convert this to a string and then take 100 times that value, and then we'll add on % on the end. So now I've got a publisher. This becomes a publisher of strings. And now I want to take the result of this and put it in there. And while you could do this with sync and get the value and then, set gas gauge equal to that value, there is a better way to do this. And of course, there's also assign to on, which would allow you to say gas gauge like this, and then assign to that on self. This is another option. Both of those options would require you to save the any-cancelable somewhere, so the subscription would stay alive. But with the published property wrapper, there's also assign to with the address of a published property wrapper's publisher. And so here I have to type ampersand $ and gas gauge. And the interesting thing about this is I've taken the output of one publisher, which is this block here, and I've assigned the output of that to the input of this one. So now this gas gauge publisher will receive these values automatically. And what's great about this is that the memory management, the subscription cancelable, is being managed internally by the published property wrapper itself. So there's nothing for me to store. This just works. And it will, once this owning type goes out of scope and gets deallocated, it will release these published property wrappers and all of their subscriptions as well. So what we have now is the ability to use that property. So I can say car.gasGauge here. So instead of using the actual level, which I can ignore with _in, if we run it there, I can use it just like a property here, and now I get 50% and 25%. But I could also use it to just print it out over time. I could say gas gauge and sync and just see all of them. I could say print $0. Stitching together combined publishers with property values like this can be a useful way of bridging between plain properties and published values. And it's so useful that we're going to use it a lot in this course. Okay, we've covered a lot of ground, but how does all of this look in an iOS app? It's time to take what we've learned and put it to use. In this example, we're going to build a simple sign-up form in UIKit. Our form is going to consist of an email address field, a password field, a password confirmation field, and an agree to terms and conditions switch. And we want to make sure that this sign up button is disabled until the form is considered valid. So the rules for our form are listed here. The email address must be valid. And for this, I'm just choosing a simple rule that's got to contain these 2 characters. The password has to be at least 8 characters. It can't be the word password. The password confirmation must match the actual password. And the user must agree to terms. And there are a couple of bonus things that we'll look at in a little bit. So right now, this is done in a storyboard, and all the events are wired up. But we're going to do all of this in code. So we're going to go back to our view controller, and we can see that there's these empty IB actions for each of the change events for each of these fields. So what we need to do is make sure that all of these things sort of participate in the combined world. And to do that, we are going to start off by creating some subjects. So let's create a quick section in here, which we're going to call subjects. And I mentioned before that subjects are a good way to take events and data that are happening outside of Combine and funnel them into the combined world. So we're going to have an email subject. This will be a current value subject with a type of string and a failure type of never. And we have to give it a value initially, so I'm going to start off with empty strings. And this will allow me to sort of avoid nils everywhere. We're not going to have to deal with nil and a blank string like you would normally have to do. We're just going to assume that we always have a value. So now I'm going to do the same thing 2 more times. This one will be for the password subject. This will be for the password confirmation subject. And then we will have one that is going to be an agree to terms subject. This one will be a current value subject with a bool and never. It'll start off as false. And so these are the subjects that we're going to use. And the reason we have those is so when UIKit tells us that the email did change, I can just take that value and send it into that subject. So we're going to take the email field, give it its text property, and nil coalesce that to an empty string because we do not allow nils to come into our subject. So now let's do the same thing for the other fields. Password subject, send the password field current text. We're going to do the same thing for the confirmation. And for the agree switch change, we'll grab the agree terms subject, send the agree terms switch, whether that is on. So now we've written a little bit of boilerplate code that's just going to take the UIKit actions and send them through these subjects, which we can now participate in combined pipelines. Now let's start off with just one rule. Email address must be valid. So let's make a function here. Email is valid, and we'll take in an email address as a string and we'll return a Boolean. So this is just going to encapsulate some business logic. This could, this code could live anywhere. It could use regular expressions if you wanted to. And for now, I'm just going to say email contains at and email contains dot. That's going to be our rule for now. Next, I want to have the notion of email being valid as a publisher of bool values. So to do that, I'm going to create a private var email is valid. And this is going to be an any publisher of bool values with no error. And we're going to have a handful of these. So I'm going to make a section like this called publishers. And the reason I do this is if we go up here to the scope bar, which you can't see because my resolution is too small right now, but you can open it up with Control-6 and it'll show you the outline of your class right here. And if you do mark:\_ like this, it'll add these dividers and give you the title. So we've got our subjects up there, we've got our view stuff, and we've got our publishers. Okay, so the email is valid is going to start with our publisher, which is the email subject. So anytime the email address changes, this is going to get a new event. And we now need to map that value to funnel it into here. So we're going to take that and we're going to call email is valid and pass in $0, which is the value that we got from the email subject. So now this is going to be a publisher of Booleans. Now, before I can continue, it is going to complain. Actually, let's first erase to any publisher so we can agree with the return type. And before I can continue, it's going to complain that email is valid is a method on self, and we need self dot to call it. Now, if I do this, I've now created a retain cycle because whoever subscribes to this publisher here is going to store this in a cancellables set, which I might as well create right now because we're going to need it. Cancellables is a set of any cancelable. And we can initialize that to an empty set. So those are going to be stored in here, and this is not going to go away until our view controller goes away. So if any of these things capture self, we're in trouble. So right here, we need to do one of two things. We can use unowned self, which in this case would be safe. So we could do this, or we could use weak self. Now I'm going to use weak self because I want to illustrate a different point. Now when we use weak self, that means self inside the block is going to be nil if the view controller ever is deallocated. But what we can see here is the value of optional type bool must be unwrapped to a value of type bool before we can return it as a bool here. So we have a few different options. One of those we've seen before is we could compact map the upstream publisher to eliminate any bools and just ignore them. And another one we could do is replace nil with some predefined value like false. So if we do this, we change the downstream publisher to one that is bool rather than an optional bool. Okay, so now we've got this publisher that's going to always publish an event anytime the email subject changes to tell us whether or not this email is valid. Now let's make a sort of a rolled up version called form is valid, which is also going to be in any publisher of bools. And here, right now, I'm just going to delegate to email is valid just to make our example work. Okay, so now before we run this, we actually have to subscribe to that. So we're going to say form is valid, and I want to assign the results of form is valid to the is enabled property on our sign up button. And then we need to store this subscription. This is kind of, we've been making sort of computed publishers that get created when you call this, and this is where we actually create the subscription on form is valid. So this is one we need to store in cancellables. So this is our only subscription. Okay, so if we run it right now, what we see is the sign up button is immediately disabled. And that's because form is valid is based on email subject, which is a current value subject. Current value subject sends the value of empty string immediately. And this is one of the differences that we have between having current value subject and pass-through subject. If we had pass-through subject, it would have to wait for that first event, but current value subject doesn't have to do that. So we get our form is valid, gets triggered, it is false, and it assigns is enabled to sign up button. So there's no way for me to sign up this form right now. So we go into our email address, and I start typing, and I add an @ sign and a dot, and as soon as I add the dot, it sets this, this returns true, which means that the email address is valid, returns true, form is valid becomes true, and that sets the button to enable. Okay, so now let's do something similar, but for passwords. And if we look at our rule for password, password has 2 rules here, actually 3 rules. Password must be at least 8 characters, can't be password, and password confirmations must match. So let's do the first two in the same publisher because it's pretty easy to do that. So what I'm going to do here is just add another publisher called password is valid. And then we can have another one that is password matches confirmation. So again, you could write all of this in one really gnarly publisher chain, but I find it really nice to just sort of zero in on one thing at a time. Let's comment that out just for a second so we can get this thing compiling. So we're going to start off with the password subject, which is going to tell us when the password value changes. And now we need to map this to check to see if $0, make sure it doesn't equal the word password and that $0.count is greater than or equal to 8 characters. Now we can erase that to any publisher. Now we've got a publisher that tells us whether a password is valid. So we've kind of encapsulated this specific, Swift code, which translates our rules into a more higher level publisher that just tells us if our password is valid. So now we have something similar here. This one needs to check to see if the latest password matches the latest value from the confirmation. So we're going to start with password subject, and we're going to combine this with the latest value from password confirmation subject. Now, when we map this, we are given a tuple of values. So this is going to be passwords, and we can say password and confirmation like that, which will kind of unwrap the tuple into these 2 arguments. And now we can just check to make sure that the password equals the confirmation. And now we can erase to any publisher. Okay, so now both of these things are important for us to know whether this form is valid or not. So if we want them to be rolled up again, we could have another password valid and confirmed. This is one way we could do it. Again, I'm kind of putting these in really small pieces because they're all easy to reason about on their own. So here I'm just going to say password is valid and combine that with the latest value for password matches confirmation. We'll map that to valid confirmed in and return valid and confirmed. Erase that to any publisher. Now we can go back up to our form is valid. And here, again, we need to do something similar. We're going to combine this with the latest value. And because I don't necessarily want to start with one publisher, I will probably use publishers.combine_latest here. And right now it's just 2 arguments. So we'll say combine latest A and B, and then I'll put email is valid. and we can put password valid and confirmed. Now we could have put both password rules here and use combine latest 3, but again, as I mentioned earlier, there's only combine latest 4. So you eventually have to start rolling these up into kind of nested publishers that kind of encapsulate this logic for you, so you don't end up with some really difficult to work with completion callbacks. So if I use just combine latest, so I've got these two arguments here. Now we can map this to make sure that they're all true. And unfortunately, there's no easy way to do this in Swift. You could use $0.1 and $0.2, etc., which, we can do this, or we can give each tuple parameter a name and, do it that way, kind of like we did here. And of course, we need to erase that to any publisher. So now what we should see is that our email address needs to be some email address, and our password needs to be something like this. And as soon as I have a valid and confirmed password, the sign up button is enabled because all three of these things are enabled. So the last piece is just to check to make sure that our agree terms switch is on, which is actually pretty easy because now I can just switch that to a combine latest 3, and I add the agree terms subject here, which itself is already a publisher that gives us a Boolean value. And now we can check $0.2, which is the last element of the Boolean. And now I'm going to run it again. Now it's going to validate that we have also agreed to the terms. So what we've seen here is we've taken these rules up here, and we've made a publisher for each one of them. And they were pretty much self-contained. These could be written by different developers. They could live in their own files if we needed them to. And they could be tested independently of everything else in the application. And then we just need to bring them all together in this form is valid publisher. So now, if you're interested, we can continue with these bonus features. So the first one is color the email field red when it's invalid, and password confirmation field red when it doesn't match the password. So let's go ahead and do that. Let's take the notion of, well, we already have the notion that the email is valid. So we can take this publisher. Actually, I think we call this email is valid. I'm going to rename this because it's a little bit confusing that it says this. I'm going to just call this is valid email like that, just to make sure that we're not confusing this one with the one that returns a publisher. So when the email is valid, value changes. I want to map this to a color. So if it's valid, we're going to use uicolor.labelColor. And if it's invalid, we're going to use uicolor.systemRed. Then we can assign that to the text color property of our email field. And because this is a subscription, we need to store this in our cancellables. Okay, let's go ahead and run that. And as I'm typing, you can see that it is red. And as soon as I type the character that makes it valid, it goes back to being label color. Let's do the same thing for password confirmation. So here we're going to say password matches confirmation. And here becomes a reason why we might want to separate the rules between password is valid and password matches confirmation, because then we can use it in a different way. So again, it's basically the exact same code here. So I can do that and just change this guy to the password confirmation field. So let's run this. And so I've got a valid email address, I've got a password, and until this password matches, it turns white as soon as it matches. Okay, and if we wanted to do the same thing to the password field, we could, because we have a password is valid publisher. But as we've seen, these two things are pretty much duplicated. So this is a good opportunity for us to say something like set, I don't know, valid color of this field, and we'll pass in a UI text field, and then have a publisher. And here we need a publisher. We need to have some notion of a publisher that has a bool, but I don't want to hard code any publisher in here. This is too much of a hard coded requirement that you would have to type erase it before using this. What's better is to leverage the Swift type system to say, you're going to pass in some P that is a publisher and use it here, but we're going to make some constraints to say that where P's output is Boolean and P's failure type is never. So all of our current ones will still match this, but then we don't have to require that everyone use any publisher just to call this method. So now I can take this code here, which I'll cut and paste here. We will change this to field, and we'll change this, or rather we'll change this one to the publisher, change this one to field, and then we can change email is valid to use set valid color for the email field, and email is valid publisher. And then we can do the same thing, set valid color on the password field. Password is valid. And then finally set valid color on the password confirmation field where the password matches confirmation. Okay, so now we've got email address valid. Password isn't valid until we get 8 characters, and then password confirmation when it matches. Okay, we have one more bonus feature, and bonus here is email address must remove spaces and be lowercase. So what I'd like to do for this one is go down to our publishers, and next to the email one, we're going to change this one. We're going to have a formatted email address. So this one is going to be an any publisher of string values, which is going to take our email subject and just map it to lowercase it and map it to trim it and trim all the characters in the white spaces and new lines set. Then erase to any publisher. So whatever gets typed is going to get formatted and sent out. So now we can actually use that here, formatted email address here. And we could also use it, when we're going to send it somewhere, we would use this formatted email address value rather than the, the current text field's value. And so then what we can do is up here, we can take the formatted email address and we can assign this back to the text property on our email field. Now there are a couple of problems here. First, we notice this kind of cryptic error message. Type of UI control has no member text. And this is a little bit weird. Now, it's saying UI control optional because this is an implicitly unwrapped optional because we're using storyboards with IB outlets, and that's how you have to do that. But it's just not smart enough to know that the reason why this isn't able to be hooked up is that this thing is producing strings, and the text property on our email address field accepts optional strings. So the types don't line up, so the compiler isn't happy. So we can make the types line up by taking this string and casting it to an optional string. And we'll have to do this a lot when we're binding to text properties on our UI text fields. So it's just something to know. We also need to store this in our cancellables set. And then the last thing I just want to touch on before we run this is that we kind of have this, this cycle that I want to break here, where a value comes in, we format it, then assign it back to the text property, which triggers the email subject to get another value, and then it gets formatted again, even though it's the same string, and then we have this sort of cycle that infinitely repeats. And so to address that, we just need something that will break the cycle. So here we can filter out values, and we can filter out values just to make sure that none of them, we can say $0 not equal the email subject dot value. Now that requires self, so let's add unowned self in. And so now we can use self inside the block here. And so if $0, meaning this formatted email address, is the same thing that was in this email subject, then we can just skip it. So let's run this. So now when I start typing capital letters, they become lowercase. If I try to add spaces, they're not allowed. So now trailing spaces or, spaces like that, it does allow spaces in the middle because we're using the trimming spaces, but we could, address that in the same way. But this is kind of a nice way of creating some consistent user input and making sure that the text field reflects what value is actually being submitted. Okay, and with that wraps up Module 2.